All right, here we're talking about trig transformations, and this is Unit 2, and this is actually incorporating a lot of topics, topics 3 through 5. And I have listed here the main things we talked about in class, the 5 different transformations that can take place. Okay, so let's just review them really quickly. Oh, this is supposed to be a D right here, sorry. The D's on the back move the graph vertically up or down, those are translations. The C inside moves the graph vertically left or right. Okay, and the B inside changes your period length. So please remember that the period length equals 2 pi divided by that B value. The A is your amplitude, and we do say that it's the absolute value of that A. Well, I used the lowercase, doesn't matter. But and then the minus or plus in front would be a reflection across the x-axis or not. Plus would leave it the way it is, and the negative would reflect you across the x-axis. Now, we talk about sine. Just want everybody to know the basic sine real quick. One sine wave looks like this. Starts at 0, up to 1, down to 0, to -1, back to 0. That is one sine wave. A cosine wave starts at 1, drops to 0, drops to -1, up to 0, back to 1. That is one cosine wave. All right? So the only other term that we didn't talk about in class is the frequency. Okay, and the frequency of one of these graphs is really just the B value. It's just simply your B value. So the frequency is how long does it take for one of these curves, or I'm sorry, how many waves occur every 2 pi. So every 2 pi, how many waves occur? So it could be more. If you shrink it down, you could have many waves inside of that 2 pi, or you could have a small amount, like you only have half or something inside of there. So again, that's pretty much just your B value, is how many waves occur inside of 2 pi. So we'll talk about that as we do some examples as well here. So what we want to do is we're going to look at some examples here one by one, and in every example we want to identify the translations, the transformations, and we also want to identify our 5 final points. Okay, so the first function here is going to be negative sine of x plus pi over 3 minus 6. So if you want to hit pause right now and try to identify the translation or the transformations on your own, and then go ahead and find the final 5 points, you can then hit play and check your work. So you can start doing that now. I'm going to start going over the answers. All right, first off, the negative out front here is going to be a reflection. That's a reflection across the x-axis. Okay, so if I want to think about what that would do, that's going to make my sine start going down and then up. So it's going to switch the wave of sine. The minus 6 on the outside is going to be a translation, or it's going to translate down 6. So this whole graph is going to shift down. And then inside, that's going to be a translate, that's going to be left pi over 3. So the whole graph is going to shift to the left, pi over 3. So let's think about the original points for sine, and that would be 0, 0. Sine starts its wave at 0, 0. Pi over 2 to 1. Pi back to 0. 3 pi over 2 down to -1. And finally, 2 pi takes us full circle back to 0. So the first thing I want to do is I want to think about, I don't want to do too much at once. I want to think about simply the reflection. The reflection is going to take the 0, 0 and leave it alone. It's going to take the pi over 2 and take it to -1, because it's going to reflect that 1 to -1. The pi comma 0 is not going to change at all. I'm reflecting across the x, so only the y's change here. 3 pi over 2 is going to fly up to +1, and 2 pi is going to go back to right where it was at 0. Okay, so that was the first thing. Now I want to take care of the rest of the translations. Okay, so one thing I like to do is write out, make my little 5 sets of parentheses. And you make them as big as you need to, whatever. Try to make them nice. So first up is that I'm going to go down 6 because of the minus 6 on the outside. So that's going to make this 0 go down 6. -1 is going to go down 6. 0 is going to go down 6. 1 is going to go down 6. And the 0 down, this is a 0, is going to go down 6 to -6. Okay. Now all of these x values need to move to the left 3, so that is subtracting pi over 3. That's what we mean by move to the left. So I got to subtract. So 0 minus pi over 3 is negative pi over 3. pi over 2. So I'm going to do some dirty work over here. Pi over 2 minus pi over 3. This is going to be 3/6 and 2/6. So 3/6 minus 2/6 is going to be 1/6. I got to do pi minus pi over 3. That's going to be 3/3. So 3/3 minus 1/3 is going to be 2/3. And I got to do 3 pi over 2 minus pi over 3. So let's see here. That's going to be multiplied by 3. It's going to be 9/6 and 2/6. So 9/6 minus 2/6 is going to be 7/6 pi. And lastly, I got 2 pi minus pi over 3. Sorry, my dirty work is literally dirty, but you should get the gist here. That's going to be, let's see here, 6/3 minus 1/3 is 5/3. Okay, so let's see here. Let's just pick one of these points and hopefully it makes sense. Just let's do the 2/3. So if I have 2/3 plus 1/3, so 2/3 pi plus 1/3 pi, that's going to be 3/3 pi. So that's pi. 3/3 pi is pi. Sine of pi is 0. The negative keeps it at 0, because that's still 0. Minus 6 is going to make -6. So I did check that one point, and it did work. So these would be my final 5 points, and I described the transformation there. So hopefully that is what you got as well. Let's check another one. Obviously, if you need to look at that longer, you can just hit pause. Okay, let's look at another one here. Let's do 3 sine of 4x. And this is going to be f of x here. Sorry, the function is 3 sine of 4x. So let's see here. There's no translations. And again, if you want to hit pause real quick, go ahead. There's going to be a new amplitude. The new amplitude is 3. So I'm now going up to 3, down to -3, right? So this would be my max at 3, my min at -3. And my new period length is going to be 2 pi divided by 4, which reduces to pi over 2. So I have a very small period length now. Now, that means that I have a frequency, and your frequency is just whatever your b value is. So my frequency is 4. So that means typically I had one wave. One wave was typically from 0 to 2 pi. Now I have 4 waves inside of that. So I'm having many more waves. So I'm having 4 waves inside of that. So hopefully that makes sense. So instead of having one wave in 2 pi, that's what frequency means. How many waves in every 2 pi? Every 2 pi, how many waves do you have? So I have 4 waves now. So I'm going to have 1, 2, 3, 4 waves. Pretty messy there, but you get the idea. All right, so let's start off with my points here. Sine is 0, 0. Pi over 2, 1. Pi back to 0. 3 pi over 2, I'm at -1. And at 2 pi, I'm at 0. So the first thing is the amplitude is going to take all of the 1 and go up to 3. The -1 go down to -3. But I want to, that's fairly easy to change. Now I just want to show my period length. Now I start at 0 and I end at pi over 2. Okay? So now that is one full period length. Okay? Much shorter, which is why there's more waves inside of 2 pi. So I got to think of a half of that. So half of that would be pi over 4. 1/4 of that, 1/4 of pi over 2 would be pi over 8. And 3/4 of that would be 3 pi over 8. Okay? And then after that, it should be fairly easy to figure out the y's. So that'd be 0. This is going to get stretched up to 3, back to 0, down to -3, and then to 0. And this really should make sense. All of these points here, right, should take me back to these original points. Let's just try this 3 pi over 8. If I plug in 3 pi over 8, the 4 is going to reduce the 8 to a 2, so I get, hey, 3 pi over 2. Sine of 3 pi over 2 is -1 times 3 makes the -3. So I did check this point, and it does make sense. Let's check this other one right here. Let's check pi over 4. If I plug in pi over 4, the 4's cancel. I just get pi. Sine of pi is 0. 0 times 3 is the 0. So hopefully it should make sense. So now one wave this up 3, down the negative 3, back to 0. This one wave, up 3, down the negative 3, back to 0. I'm having 4 of these waves inside of 2 pi. That's my frequency. So one of these waves is going to occur from 0 to 2, or 0 to pi over 2. So much, much faster, much more waves there. Okay, let's try another one out here. Okay, this next one is going to be f of x. Let's see here, negative 5 cosine of x plus 7. So notice that there's no parentheses here, so this plus 7 is on the outside. So again, hit pause if you want. The plus 7 is on the outside, so that's going to be a translate up 7. Don't forget about that negative there. That is going to be reflect across x-axis. And the 5 here is going to be an amplitude change. My amplitude is now 5. Sorry, I had a sneeze there. That was the first, video first, right there. Mark it down in your notebooks, video first, to sneeze. So anyway, so translate up 7, reflect across the x-axis, and my amplitude is going to change to 5. So cosine, remember it's 0, it starts up at 1. At pi over 2, it's now at 0. At pi, it reaches its min of negative 1. At 3 pi over 2, it's back to 0. And at 2 pi, it's full circle all the way back to 1. So one normal-looking cosine wave is that. I'm now stretching that up to 5. So it's now going to go up to 5 and down to negative 5. Okay, it's pretty bad drawing there. The whole thing's going to get moved up 7, but again, it is going to be reflected. So I usually like to, I'm telling you, much easier if you take care of the reflection first. It's going to reflect that 1 down the negative 1. The zeros will not change at all. Reflections do not change, obviously, 0. If you reflect 0 across itself, it's still 0. The negative 1 is going to go up to positive 1. The 3 pi over 2 is still going to be at 0, and the 2 pi is going to be at negative 1. So let me just get a quick look at what that's going to look like graphically. So it's going to start here at negative 1, go up, and then back down. So that's your cosine wave. All right, now the rest of it should be pretty easy. I took care of the reflecting across the x. Now everything's going to be moved up 7, and the amplitude is going to be changed to 5. So none of the x's are changing at all. Notice nothing happened inside of cosine. That's a good sign. That means you don't have to worry about changing the x's at all. Okay, so let's try to make sense of this. Ready? This is going to be stretched down to 5. Down to negative 5. But then it's moved up 7, so that's going to be a 2. This guy right here, 0, the amplitude is not going to change at 0, so it just moves up 7 to 7. Let's see here. This guy was at 1. He's going to be stretched down to 5 now, or up to 5, because of the amplitude change, but then it goes up 7, so that's going to be at 12. And let's see here. This guy was going to stay the same, 3 pi over 2. The 0 stays there, but it's move up 7, so it'll be at 7. And the 2 pi here was down at negative 1. It got stretched to negative 5 because of the amplitude, and then it's going to go up 5, or up 7, excuse me, to 2. So if you think about this, it's, we're going from 2, up 5, up 12, back to 7, back to 2. Okay, so hopefully this transformation makes sense, especially with the amplitude change and the translation up. Hopefully that makes sense. This negative 1 went down to negative 5, and then it had to go up 7 to 2. This one just went up 7. This guy had an amplitude to 5, and he went up 7 to 12. So if you think about this, its center line here was 0, but now it moved up to 7. And since it's up to 7, now that amplitude is going to shoot up to 5, down to 7. Okay, now I'm really making a mistake there. That was the sine curve, so I'm sorry. Remember, it was up here doing this. It got reflected, so that's why it starts here at 2, goes to 7, goes up another 5 to 12, back down to 7, back down to 2. So that's going to be that change. So hopefully that makes sense. Sorry, it was a little bit confusing, but hopefully that should make a lot of sense to you. All right, let's slide over here. So down, no room down. Okay, here's a fourth one for you guys to work on here. Let's see here. F of x. This is going to be a weird one. I'm going to make this one really different, okay? 9 cosine of pi x over 4. Very interesting. All right. Go ahead and hit pause if you want to try it on your own. This is a tricky one, though. Okay. The 9 is the amplitude. That's fairly easy. So the amplitude is 9. So again, this is my cosine curve. It's going to start up here at 9 now, and it's going to go down the -9 to 0 up to 9. So it's really stretching that out. My period is going to make a really weird change here. Get ready for this, okay? My period is going to be my b value real quick. My b value is everything but the x. So it is the pi over 4. So my period is going to be 2 pi, using the formula, 2 pi divided by pi over 4. That is the same as 2 pi times the reciprocal, which is 4 over pi. Get ready for this. Pi's cancel. I get 8. So my period length is 8. Very weird period length, 8. So it's going to take 8 for this whole cycle to stop. It's going to stop at 8. It's going to start at 0, stop at 8. Okay. So cosine 0, 1. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. 2 pi, 1. Okay, amplitude's easy. Amplitude is easy. 1 gets stretched up to 9. -1 gets stretched down to -9. 1 gets stretched up to 9. Okay, the zeros aren't going to change because they're the center points, right? They're the points right here in the center. They don't get affected by the amplitude. Now, we have a full period starting at 0 and ending at 8. Okay, so my frequency, we talked about the frequency. My frequency is just my b value, pi over 4. So that means that I have pi over 4 waves, which is a weird number because the pi is there, but I have pi over 4 waves, right, inside of 2 pi. So very weird, but that is what it would be. Okay, so half of 8 is 4. A quarter of 8 is 2. 3/4 of 8 is 6. Okay, so it's kind of actually nice. This works out very nice. Again, this has to be my half a period. Half of 8 is 4. This is a quarter of 8. A quarter of 8 is 2. And this is my 3/4. 3/4 of 8 would be 24/4, which is 6. And then this would be up to 9, to 0, down to -9, to 0, to 9. So kind of a weird problem, but it does work out fairly nice. My answers here do not have pi's in them because the period canceled the pi's out. So, normally, remember 2 pi is really about 6.28, but now I'm taking 8 to do a full period instead of 6.28. So that's why I have a fraction of a wave inside of that 2 pi. I don't even have a full wave in there. Okay, so kind of a weird problem, but should make sense, I hope. A little different. All right, and let's take a look at one more problem here. Okay, one more. This will be number 5. F of x, the function is -3 sine of x over 6 minus 4. All right, so go ahead and pause if you want. All right, let's see here. So the first thing I notice is I'm going to translate down 4. Translate down 4. Next thing I notice is there's going to be an amplitude change. The amplitude is going to stretch up to 3. So these two things together are going to really mess with my y. So I got to be really careful thinking about this because anything on the outside is with the y. Inside is going to be my period. So I notice that my period length is going to change considerably. It's going to be 2 pi divided by 1/6. The value in front of there, the b value inside of there, is 1/6. Again, anything being multiplied by x, that would be 1/6x, right? So that's when I multiply by the reciprocal, I get 12 pi. So it's going to take 12 pi for one wave. So that's why my frequency is 1/6. So again, frequency is how many waves you have in 2 pi. Well, it takes me 12 pi for a full circle right now. 12 pi for a full wave. So in 2 pi, I'm only going to see a 1/6 of a wave inside of 2 pi. So frequency is how many waves you have inside of 2 pi. All right, and one more thing there is a reflection. I love to take care of reflections first, and I would really advise that to you guys as well. Reflect across the x-axis. I would really take care of that first. It makes it a lot easier. So sine 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and at 2 pi, I'm at 0. So the reflecting is only going to change the 1. It's not going to change the zeros. So I get 0, 0, pi over 2, -1. So it's going to start down to negative. Pi at 0. At 3 pi over 2, I'm at positive 1. And at 2 pi, I'm at 0. Hopefully that makes sense. Again, sine, because it was reflected, it's now going to go down and then up, just like that. So hopefully that makes a lot of sense. All right, now let's see here. Let's tackle, oh boy, let's tackle the period first. Let's tackle those x's first. That's usually the trickiest, okay? So again, we start at 0, but now a full circle happens, or a full wave happens from 0 to 12 pi. So this middle value is half of 12 pi, which is 6 pi. This is a quarter of 12 pi, which is 3 pi. And this is 3/4 of 12 pi. 3/4 of 12 pi is 9 pi. Okay, so a much bigger period length here. Much, much bigger. Okay, now for the y's. Let's think here. Got to really be careful. 0. Amplitude does not affect 0 at all because that was the original x value. It's not going to get amplitude at all. It's not going to change at all. So it's going to stay at 0. But I do have to move it down 4. So that's going to go to -4. The -1, amplitude-wise, is going to stretch that to -3 because of the amplitude. And then it's going to go down 4, so it's going to go to -7. The 0, once again, is not going to change in terms of amplitude, so it's going to translate down to -4. This is 1 is going to make an amplitude of 3, so that amplitude is going to go up to 3 now, but then it's going to go down 4 to -1. And this 0 amplitude will not affect the 0 at all, but it will affect the translation, so it's going to go down 4 to -4. Once again, this should make sense, right? It got reflected real quick there. It then got moved, and then the amplitude changed, so it went down to 3, up to 3, so the amplitude got bigger, and then the whole thing shifted down 4. So I should still have that amplitude, right? From -4 to -7 should be a difference of 3, my amplitude. Same thing from -4 to -1. My difference there would be my amplitude. So hopefully those problems make sense. What we're going to do in class on Wednesday is a lot of practice with these, making sure you know how to do this as well. So practice, practice, practice. Hopefully you try out these problems, and hopefully these problems make sense at least. It'll go a far way in helping you do the worksheet activity and eventually a test over all this stuff. All right, thanks guys.